So here's something kind of paradoxical to chew on. Imagine running an AI model. It knows as much as like a massive 1 trillion parameter machine, but it runs with the speed, the latency, the cost of a model that's, what, 30 times smaller? Only 32 billion parameters active? That kind of efficiency.
Right.
It's genuinely stunning from an engineering perspective.
Right, and this is in vaporware, not some research paper dream. It's Kimi K2 Thinking, built by Moonshot AI, and it's the open source challenger that's, well, it's really shaking things up. Because independent leaderboards, they now show it sitting globally at number 2, just right behind GPT-5.
Welcome to the Deep Dive. Today we're taking a close look, a measured look at the source material we have on Kimi K2 and, what this really represents for the whole AI landscape. It feels like a pretty big shift.
Yeah, our mission today is kind of threefold. First, we're going to really dig into the architecture, the engine under the hood, right? What makes Kimi K2 so powerful but also so efficient, so affordable? Second, we'll look at the benchmarks. The proof, essentially, that open source isn't just catching up anymore. In some ways, it's actually pulling ahead of the big closed source players. And finally, we need to unpack what this means. The implications for things like data privacy, cost control, corporate independence even. It's pretty revolutionary stuff.
Okay, let's start with that core tech then. The big question is how? How does Moonshot AI get this massive power but keep the efficiency so incredibly high?
It really comes down to the architecture. They're using what's called a mixture of experts model and MoE. So instead of one giant brain that lights up everywhere for every query, think of it more like a huge team, a team of very specialized experts.
Okay. So if I ask a really specific, complex question, maybe something technical about, I don't know, protein folding, the system is smart enough to route my query only to the few experts who actually know about protein folding. And the rest kind of stay quiet.
Exactly. That's the core idea. In simple terms, MoE is a vast network that only lights up key sections. It achieves what they call sparsity.
And that sparsity, the fact that most of the network isn't being used for any given task, that's the key to the efficiency numbers. So the total model size, the whole knowledge base is indeed that massive 1 trillion parameters, right up there with the biggest models out there.
But, and this is the kicker for any single request you make, the activated parameters, the parts that actually spin up and generate the answer, only 32 billion. That's just 3.2% sparsity. So you're getting this incredibly deep knowledge base. But the speed, the cost, it feels like you're running a much, much smaller model.
That's a huge strategic advantage, isn't it? Just from an engineering and cost perspective, it completely changes the deployment economics.
Yeah.
If you only need to power up 3.2% of the network, you're drastically cutting down the compute needed, the energy draw, the chip requirements for inference.
Oh, absolutely. Think about traditional dense models. Every single parameter is involved every single time. That takes immense continuous power. But Kimi K2's MoE design, it means companies can scale up how many queries they handle without needing exponentially more hardware. It makes top-tier AI suddenly much more accessible, runnable on, let's say, less extreme hardware clusters.
And beyond just the efficiency, the capabilities themselves sound pretty formidable. Context length is 256,000 tokens. That's definitely big enough to handle whole code bases, right? Or long legal docs, years of financial reports, maybe all in one go.
For sure. And then there's this other metric, the agentic capability one, sequential tool calls. The sources say Kimi K2 can handle 200, maybe 300 plus tool calls in a row without a human stepping in. That means you can give it a really complex multi-step plan, something like analyze sentiment for these 5 stocks, pull relevant news from the last quarter, draft a summary email, schedule the meeting, and it can just go and execute almost that entire workflow autonomously.
Okay, that's impressive. 300 sequential steps without intervention. So, given that capability, what's the biggest hurdle people actually face when they try to use this for really complex autonomous agent tasks? Where does it still struggle?
Yeah, that's a good question, honestly. I still wrestle with prompt drift myself sometimes, keeping agents locked onto the original goal across really long workflows. It's kind of like, giving someone a 10-step task. By step 7 or 8, they might just slightly misunderstand the original intent because of tiny errors building up.
That makes sense. A bit of cumulative error. Okay, that vulnerability is important context. Now let's shift to the proof, the numbers, the benchmarks that seem to back up this claim that open source is really competing at the top level now.
Right. This is where the story gets really interesting. So for general reasoning, and especially in these agentic benchmarks testing how well it uses tools and follows multi-step plans, Kimi K2 is consistently beating several top closed source models. It just seems better at actually applying its knowledge through tools.
And coding. The results there sound pretty clear-cut. The sources mention competitive programming challenges, and Kimi K2 apparently got the highest score, decisively beating Claude 4.5. That points to really strong logic and code generation.
Yeah, really strong. And even in like high-level academic stuff, they use this tough benchmark, GPQ-A, Diamond, graduate level science questions. Kimi K2 is a beast there too. Beats Claude 4.5 again pretty handily. It's only slightly behind Grok 4, scoring like 87.5%. Really impressive.
But the big headline, the thing that really feels like a turning point, is that independent global leaderboard ranking. For so long, the top spots, maybe the top 5, were all proprietary models, closed systems. Now you look at the list, and okay, GPT-5 High is number 1, yes, proprietary. But right there at number 2, globally, it's Kimi K2 Thinking.
An open source model, sitting higher than Grok 4, higher than Claude 4.5, higher than Gemini 2.5 Pro. It's huge validation for this whole MoE approach. And, if performing at that level wasn't enough, we absolutely have to talk about the cost.
Right, because Kimi K2 is apparently way cheaper than the other top models. The numbers suggest it's roughly 3 times cheaper than GPT-5.
Yeah, around 3x cheaper than GPT-5. But the gap gets even wider compared to some others. We're talking like a 6-fold cost advantage over a Claude 4.5 and Grok 4. 6 times cheaper. And remember, you can potentially run it on less expensive hardware because of that sparsity. So the TCO, the total cost of ownership for a business, it just plummets.
So that leads to the practical question. Does that huge cost saving, maybe 6 times cheaper, does that outweigh the perhaps very small performance difference compared to the absolute number 1 GPT-5 for most everyday business uses?
I think for most professional use cases, yes, the massive cost savings are an easy choice. The value proposition is just incredibly strong.
Okay, this leads us nicely into the more philosophical side, which might actually be the most critical part of this whole story. Moonshot AI didn't just build this incredibly powerful model. They decided to release it with open weights. We should probably clarify what that means exactly.
Right. Open weights means the core of the model, the actual trained parameters, that 1 trillion number is freely downloadable. Anyone can grab it and run it. It's not quite fully open source like, say, Linux, where maybe all the training data and code are also open. But the model's intelligence, its brain, is out there.
And we should probably stress who this is really for. This isn't something you just, download to your laptop on a whim. That model file is apparently around 600 gigabytes. You need a serious GPU cluster. Right. We're talking potentially hundreds of thousands of dollars in hardware to run it well.
Exactly. It's aimed squarely at companies, serious research labs, developers building significant applications. And it's a very strategic move, really. It's positioned as a direct answer to what some people call the closed source problem that's kind of dominated high-end AI until now.
And that problem, that basically means being totally reliant on a few big, mostly American AI labs, which creates some real strategic vulnerabilities for businesses in other countries.
Absolutely. You've got serious vendor lock-in. Your entire AI capability could depend on one company's pricing whims or sudden policy shifts. And critically, the data privacy issue is huge. To use those closed models, you have to constantly send your sensitive proprietary data out to their servers for processing. There's often very little transparency into how it's used or secured. It's complete dependence.
So the open source approach, particularly with a powerful model like Kimi K2, available with open weights, it just flips that whole dynamic. It offers data sovereignty.
Total data control. Because you download the model, you run it on your hardware inside your secure perimeter, your confidential health data, your financial projections. They never leave your infrastructure. Plus, you get full control over customization. You can fine-tune it deeply for your specific industry or tasks. And crucially, you gain independence from external pricing, external rules, external regulators.
It must have taken a massive commitment, though, for Moonshot AI to spend what must have been astronomical sums developing something this close to GPT-5 level. And then essentially just give the engine away for free.
It really is like a gift to the global research and development community. It just turbocharges innovation everywhere because now everyone can access and build on a truly state-of-the-art foundation model.
Whoa. Imagine scaling to 1 billion queries without reliance on external companies. That's just pure innovation fuel for countless startups, for corporate R&D labs everywhere.
And it puts immediate, intense pressure back on the closed labs. They now have to really justify those high subscription fees when something this good is available for free, provided you have the hardware.
So putting aside the competitive angle for a second, what do you think is the single biggest benefit for global AI research when a foundational model this powerful is made open like this?
Accelerated research happens because everyone can now build directly on a state-of-the-art foundation. It just raises the baseline for the entire field almost overnight.
Okay, so let's get practical. How can someone listening right now actually access this power? Sound like there are basically two main ways. Option one, the simplest path, is just using their online interface, right? At Kimi.com.
Yeah, but the key there is you have to remember to enable thinking mode in the settings to actually access the Kimi K2 power. And that online version already has some pretty capable agent modes built in, like OK Computer for coding, which sounds quite autonomous, and Researcher for digging through and summarizing data.
And then option two is for the, let's say, power users, the enterprises, the researchers needing maximum control. That's the local on-premise deployment, downloading the weights from Hugging Face. That's the route if you're dealing with highly sensitive data like health or finance and need absolute 100% control.
Exactly. So let's kind of sum up where Kimi K2 really shines, its superpowers, if you will. First, definitely coding and software development. The reasoning ability for code seems top-notch. Second, building AI agents. That high number of sequential tool calls makes it ideal for complex autonomous tasks. Third, probably high-level scientific and financial research. It seems exceptionally good at pulling together and reasoning over complex technical information. And of course, anytime cost is a major factor or when data privacy is absolutely mandatory.
But we should be fair and note where the alternatives might still have a slight advantage. GPT-5, for instance.
Yeah.
The sources still suggest it might be a bit better at extremely complex, maybe more creative or abstract tasks.
Right, they mentioned things like the beehive simulation example, scenarios needing really complex, maybe edge case physics understanding. Kimi K2 apparently struggled a bit more there. So it suggests that while the general knowledge is vast, maybe the absolute peak of abstract complex reasoning isn't quite at the GPT-5 level yet. Minor gaps.
And context window length is another one. If you absolutely need the biggest possible window, say you're feeding it a massive 900-page book or dozens of dense PDFs at once, Gemini 2.5 Pro's 1 million token window is still the leader there, right?
Correct. So yeah, the trade-off seems pretty clear. You might accept a tiny, maybe negligible hit in absolute top-end edge case quality, but in return, you get enormous gains in openness, total data privacy if you run it locally, and that, potentially six-fold cost efficiency.
So final question on readiness. Considering those known weaknesses like edge case physics, some minor layout bugs mentioned, is Kimi K2 truly ready for mission-critical, high-stakes business use today?
I'd say yes, especially for privacy-critical work. The ability to have complete control over your data often outweighs those known minor bugs. That independence is frequently the deciding factor.
Okay, let's try and bring this all together then. The core thesis of our deep dive today. It seems to be that Kimi K2's success really proves that open source AI isn't just playing catch-up anymore. It's actually leading in some really important areas. And it's firmly established itself as a peer, performance-wise, to the big proprietary models.
It really feels like a historic shift. Think back just a few months. The top 5 models on those leaderboards, all closed systems. Innovation locked behind paywalls. Now, the number 2 spot globally is held by an open source model. That puts incredible pressure on big tech. They have to innovate faster, sure, but they also probably have to bring prices down for everyone needing AI.
So for you, the listener, the takeaway is that you now have a real, meaningful choice. It's not just about convenience versus nothing. It's convenience versus this potent combination of power, privacy, and cost control if you go the open way route.
Yeah, so maybe here's a final thought to leave you with, something to mull over. If a top-tier open source model can basically match performance in most areas while potentially costing 6 times less to operate, what really is the long-term sustainable value proposition for the closed models? How are they going to justify that significant price premium going forward?
Definitely something to think about. We encourage you to check out the sources, look at the leaderboards, and consider what this shift means for your own work or research. Thanks for joining us on this deep dive.